The United States is one of the largest ammunition producers in the world, manufacturing nearly 10 billion rounds every year. But have you ever wondered how they are made and how factories can control every single round among billions of products? Stay until the end of the video to witness the process of producing billions of rounds of ammunition, where engineering, speed, and precision come together inside a massive manufacturing system. The history of ammunition began more than 700 years ago, when gunpowder first appeared and gradually spread into Europe through trade routes. Early cannons and muskets were extremely primitive. Soldiers had to pour gunpowder by hand, load a lead ball into the barrel, then ignite it to fire. Reloading a single shot could take nearly a minute, and accuracy depended almost entirely on luck. Everything started to change during the 19th century, when the Industrial Revolution transformed weapon manufacturing from handcrafting into mass production. The invention of metallic cartridges made ammunition safer, more resistant to moisture, and significantly increased firing speed. Today, the American ammunition industry can produce billions of rounds every year using highly precise automated production lines. In today's video, we are going to explore how some of the most advanced ammunition factories in the United States actually operate. Everything begins with metal. Large brass sheets are rolled thin and formed into massive coils. At this stage, the material still does not resemble a bullet, but it already determines most of the final product quality. The metal coils are sent through inspection systems where machines measure thickness, hardness, and material consistency. If any deviation is detected, the material is rejected immediately. After that, the metal surface is cleaned to remove oil and impurities left over from the rolling process. At this point, everything still looks very rough, but the stability of the material during this first stage will determine whether the following processes run smoothly or not. From the metal sheets, stamping machines cut small discs, then press them into shallow cylindrical shapes with thin walls and a solid base. This is the first step of transforming flat metal into a three-dimensional form. But the process does not stop there. These metal blanks are then transferred through multiple deep drawing stations, where they continue to be stretched and shaped into complete cartridge cases. At each station, the blank is forced through a smaller die, stretching the metal and thinning the walls. After each deformation, the metal becomes harder, so it must be heat-treated to restore flexibility. This draw and anneal cycle repeats several times until the case reaches its final shape and dimensions. Once the basic form is complete, the case moves to base machining, the area that experiences the highest pressure during firing. Machines reinforce the base to make it thicker and stronger. Next, the primer pocket is precisely stamped or drilled into place. Identification markings are also stamped onto the base for traceability. How much pressure do you think builds up inside a cartridge case when it is fired? After machining, the cases still contain oil residue and microscopic metal fragments. To clean them, they are placed into rotating tumblers filled with abrasive material, usually crushed corn cob media. As the cases rotate, they constantly collide with both the media and each other, polishing the surface and removing tiny contaminants. These metal particles are too small to see with the naked eye, but if left behind, they could cause malfunctions later. The bullet-making process begins with metal cores formed into long wires, which are then cut into small pieces with extremely precise weights. These cores are made from specially adjusted alloys that are hard enough to maintain shape, but still soft enough to perform reliably during use. After cutting, Each core is inserted into a thin copper jacket that has already been preformed. This jacket is a short cylindrical shell designed to surround the core. Next comes the forming stage. A powerful press compresses the core and jacket together. Under high pressure, the metal jacket deforms without cracking and tightly wraps around the core, creating a unified structure. The bullet is then pushed through multiple dies to refine its final shape. Each stage gradually adjusts the design until the bullet reaches its finished form, including the body, tip, and slightly tapered base for improved flight performance. Every detail during this step must remain perfectly consistent to ensure stable performance. Inside the production line, primers are supplied as pre-manufactured components and handled under tightly controlled conditions. Instead of being produced directly on the main floor, primers enter the assembly system already prepared for installation, reducing unnecessary handling of sensitive materials. At the assembly section, cartridge cases move continuously through machine stations where primers are inserted precisely into the base of each case. The process is fully automated, with carefully controlled pressure to ensure every primer is seated correctly. Reducing manual handling minimizes inconsistencies and improves product uniformity. Throughout the process, the cartridge cases remain fixed while moving through a repeating cycle, ensuring every primer is installed under identical conditions. The system operates continuously at high speed while maintaining the precision required for each step. After the primer is securely installed into the base of the case, each cartridge continues along the production line into the propellant loading stage. This step directly determines the energy of the round and is therefore strictly controlled throughout the entire manufacturing process. Automated systems dispense a precise amount of powder into every case. Metering mechanisms operate continuously to ensure every load is identical. The propellant is not poured randomly. It is controlled by extremely tight weight tolerances because even a tiny variation can affect performance. During this process, cartridge cases move continuously along conveyors and pass beneath loading stations one after another. Every station is synchronized to maintain high production speed while preserving accuracy. No part of the process is done manually. Everything is automated to minimize errors. Once powder loading is complete, the cartridge cases immediately move into the final assembly stage, where every component is joined together with high precision to complete the product. The entire process is handled by automated machinery. Bullets are fed through a separate line and positioned into the case mouth at a predetermined alignment. At the seating station, presses insert the bullet into the case to a carefully controlled depth. The cases remain fixed throughout the process to prevent misalignment. Every movement follows a repeated cycle to ensure all rounds are assembled to the same standard. After the bullet is seated correctly, the neck of the case is crimped tightly around it. This secures the bullet in place and prevents movement during transport or use. Both seating depth and crimping force are maintained consistently across the entire production line. At the end of this stage, each round has become a complete cartridge with all components precisely connected. Every round continues through inspection systems where machines evaluate the product with extremely high precision. Each cartridge is checked for dimensions, shape, and consistency to ensure it meets standards before leaving the production line. In addition to automated inspections, random samples are selected for live testing. Some may be placed into simulation devices or fired to evaluate real-world performance. If any abnormality is detected, the entire production batch may be rechecked to ensure no defective products remain. Inspection does not happen only once. It takes place continuously throughout the production process. This allows problems to be detected early and ensures every cartridge meets required standards. If even a single deviation is discovered during inspection, the entire batch can immediately be placed on hold while the cause is investigated and corrected. Only after passing every strict inspection stage are the finished batches moved into packaging, where safety, traceability, and regulatory standards are carefully maintained. At this stage, cartridges are arranged into rows and placed into pre-formed trays. The tray design keeps each round securely separated to prevent direct contact during transport and storage. At the same time, automated counting systems verify the exact number of products in every package. Each loading cycle is monitored to ensure consistency between boxes and reduce errors compared to manual handling. Once the required quantity is reached, the trays move into boxing stations. Machines automatically fold the boxes, insert the trays, then seal the packages shut. Next comes labeling. Important information such as ammunition type, caliber, production lot number, and tracking codes are printed clearly on every box. These details play a critical role in quality control and traceability if needed later. The completed boxes are then grouped into larger containers, stacked onto pallets, and transferred into storage areas. There, the products are kept under suitable conditions before being shipped to distribution points. The production line does not only manufacture products, it also continuously handles all excess material generated during machining. During processes such as stamping, cutting, and sizing, leftover metal pieces and defective products are unavoidable. Instead of being discarded immediately, these materials are collected directly from the line and removed from the main production flow. In practice, small metal scraps from cutting and forming are separated and stored according to material type. This makes downstream processing more efficient. Defective or rejected products are also isolated to prevent them from mixing with approved production batches. After collection, all excess material is transferred to a dedicated processing area. From there, it may be recycled or treated according to the requirements of each material type. Separating materials from the beginning helps reduce waste and recover valuable resources for future production. This part of the process often receives little attention, but it plays a major role in maintaining both efficiency and sustainability across the entire manufacturing system. From the first brass coils to the moment finished cartridges leave the production line, everything we have seen today is not a simple one-step process, but a tightly controlled chain of operations. This is clearly more than just a normal factory line. It is a highly coordinated system where every small detail is monitored to guarantee the final result. If this journey helped you better understand a process that very few people ever get to see directly, leave a like so I know you found the video useful. If there is any part of the production line you would like to explore in greater detail, leave a comment below. And do not forget to subscribe for future videos.